going to look at into electrolysis a little bit deeper. And this is the electrolysis of sodium chloride solution, NaCl, AQ. So there's also H2O present, which we'll come back to in a short while. And we're having to make the electrolysis visible so you'll be able to see the motion of ions during electrolysis. So we're not only looking at the products of electrolysis, but can we determine the rate? So the first thing we have to do is to set up an electrolytic cell with sodium chloride as the electrolyte, and then we're going to add potassium manganate 7, also known as potassium permanganate crystals, which will enable us to determine the rate of movement of ions during the electrolysis. So here's the apparatus, a diagram of it. Of course, the wires don't have right angles in them, but the schematic here, it makes it more straightforward to see what's happening. And here are the labels, terminals at the top, an ammeter to measure current, the electrodes which dip into the electrolyte, and pause it if you're going to make your own copy of the diagram. Current about 2 amps or less. With sodium chloride, you don't want to leave the electrolysis running really for more than a few seconds. So we're going to see, oh, there are bubbles, but look, the bubbles aren't even. On the positive electrode, the anode, there are fewer bubbles compared to the one on the right, the cathode. And what is actually happening with dilute sodium chloride solution? Hydrogen is formed at the cathode, and that's the one on the right, where hydrogen ions from the water, which contains very, very small amounts of H plus and OH minus, but when you remove them, another water molecule dissociates into ions. And so you need 2 electrons to make 1 hydrogen molecule. And if you look at the lower of the 2 equations on the right there, you need 4 electrons which are released when 1 molecule of oxygen is formed. So for 4 electrons, you'll produce twice the amount of hydrogen. And a reminder here that it's all about preferential discharge. So sodium and hydrogen are positive ions, and it's going to be the one that takes less energy to be discharged, the one with the lower electrode potential. Actually, here we've got hydroxide and chloride ions, and again, less energy to discharge the hydroxide ion. And we're going to put a little bit of potassium permanganate, few crystals, because of its purple color. Now, it dissolves, it spreads, diffusion takes place because of the kinetic theory and the movement of the water molecules. And this is what you see. So it's spreading, but what can you see about the electrodes that are dipped in there? Is there any significant spread? So we see to the right there, to the left, going to the anode. So the negative ions, the MnO4 minus ions, are traveling to the positive anode. A little bit of a diagram here showing what is actually happening, and recognizing it's going to spread in all directions, but increased spread of the negative ions to the anode. And you've got to think here, what else could you do with this apparatus and the same materials? What measurements would you actually take to determine the speed of the ions, here the MnO4 minus ion? And even further investigations with the same apparatus what different materials might you choose to investigate something similar that will tell you more about electrolysis and the speed of ions. Hint perhaps, MnO4- is a single negative charge. So there are several things that you can think about. And as always, with many thanks to Washington International School and their team science, and in particular Mr. M's IB physics class. Thank you.